Okay, welcome to the MCA type videos that we're going to be putting out online. We are currently about 2 weeks away from our math MCA, and we took a practice test, and what I've done is kind of picked out some things that we want to make sure we review and kind of add a couple things that maybe we didn't quite hit on, just so we see them right before we get there. So today we're talking about proportions. We've already talked about proportions, but I saw a couple questions on the practice test that there were things that we could do, but we may not have seen a whole lot when we first went through proportions. And actually, we've been doing proportions pretty much every day since we've learned them, at least with our power-ups and things like that. And a lot of times I put these types of questions on our homework assignments. But we're going to start with the most basic definition of it, and proportion is a statement that two ratios are equal, and we say 2/4 and 6/12 are equal, and they form a proportion. And that should be true because both of these fractions reduce down to 1/2. Divide this by 2, you get 1. Divide this by 2, you get 2, so 1/2. 6/12 is also 1/2. We divide by 6 for both of those. Couple relationships here. It says right here they both reduce to 1/2, and there's different multiplication relationships within these to get from this side to this side. So from here to here, if we multiply by 3, 2 times 3 we get 6, 4 times 3 we get 12. So that's what these are saying. If we look down, 2 times 2 is 4, and 6 times 2 is 12. So they have all these sorts of relationships that we can use to go back and forth. We've also used cross product, which will come up later, but we're not going to get into it too much today, at least for solving for a variable. But if we do this cross product, 2 times 12, 2 times 12 is 24, and 4 times 6 is also 24. And so with proportions, cross products are equal to each other. So cross products, and you'll notice we've used the cross multiply divide to solve for a variable before. And the reason is because when we do the cross products, they are equal in proportions. So they have a lot of cool little facts about them that we've used as we've gone through. But some of the things that, solving for a proportion is pretty easy. We have a lot of ways we can do that. But more so what we want to think about, especially on the MCAs, is taking different scenarios and figuring out if they're proportional or not. So that's what this example is asking. It says, to park for 2 hours, a lot charges $3. To park for 3 hours, the lot charges $4. So we kind of look at it like this. We've got, for 2 hours, $3. 3 hours is $4. So we look at these fractions, or the ratios. And if we have a proportional relationship, these two fractions should be equal to each other. However, they're not, and they will never be equal to each other, no matter, they're both in their most simplified form. There's nothing we can do to change them, and these ratios are not equal. So that symbol right there means not equal. And since they are not equal, this is not a proportional relationship because we do not have equal ratios. So that's a no, not proportional. However, this example is proportional. It says Nora is paid $12 an hour. Is her pay proportional to the number of hours she works? Let's look at it. We've got hours and pay, or money, dollars. So for 1 hour, she'll get $12. 2 hours, she'll get $24. 3 hours, $36. And it keeps going on like that. So we could take any one of those, and all three of these, and any other ones that we would list, would be equal to each other. 1/12 equals 2/24 equals 3/36. Because we should be able to see that all of those are equal to 1/12. The second two fractions we could reduce and they would turn into 1/12. Divide this by 2, you get 1. Divide this by 2, you get 12. Divide by 3, you get 1. Divide by 3, you get 12. Okay, so this is a proportional relationship. And what we actually look for is a common factor. What is our common factor? And what are we multiplying by here to get over to here? Well, it's 12. 12 is our commonality. So 1 times 12 gets us here. 2 times 12 gets us here. So we're looking for that common pattern, basically. If it has that, we have a proportional relationship. So yes, and this one was no. Oops. All right, this one real quick. This one's about a paper route, and it says if he works by himself, the job takes 60 minutes. So we're talking about people, how many people we have, and time in minutes. Okay. So if there's just one person himself, it takes him 60 minutes. If he splits the route with a friend, it takes him 30 minutes. So that's 2 people, 30 minutes. And if 2 friends help, that's 3 people total, it takes 20 minutes. Is the amount of time it takes to complete the route proportional with the number of people working? Alright? This would be a no. Okay? We don't have that pattern. We don't have a common, how do we get from here to here? Looks like this is 1 times 60. This would be 2 times 15. And this one's a decimal, whatever you multiply by to get 20. Excuse me. So, this is a no, because if we take these fractions, once again, 1 over 60 and 2 over 30, those are not equal, okay? Those aren't equal. As long as two fractions aren't equal to each other, or 2 ratios, as soon as there's 2 that are not equal, this will not be a proportional relationship. So this is a no as well. We don't have that common factor that we were talking about. Okay. Okay, now I brought this up before, solving proportion. So for instance, solving for x here, that is, we've been covering that quite a bit. You can always cross multiply, divide to do that. So 8 times 6, cross multiply, and then divide by the 1 diagonal from the letter. That'll tell you what x is. However, that's not the only way that you can solve. There are a lot of different ways you can do it. This is one that you can always do. And remember the reason being because 8 times 6 will be equal to 2 times x. So these cross products are equal to each other. 8 times 6 equals 2 times x. And then if we want to solve for x, we end up dividing by 2 at the end. So it's 8 times 6 divided by 2. And that's because those cross products were equal. Like we got with that first example where we got 24s, 2 times 12 and 6 times 4 in that first one back here. Remember we did the cross product, 4 times 6 was 24, 2 times 12 was 24. Alright, we're not going to go through these, and obviously there were some other ways we could have done. 6 divided by 2 is 3, so we know that 2 times 3 gets us to 6, 8 times 3 will get us here. That's just another way we could have done it. And like I said, we've gone through these, and we've gone over some ratio ones too. Real quick with this one. The ratio of boys to girls is 3 to 4. If there are 12 girls, how many boys are there? We use those ratio tables that we would set up, and we covered that too. So if we did this one real quick, boys, girls, 3 to 4, so we have a ratio, actual, that's what we did. Just like that. And it was 3 to 4 for boys to girls, And if there are 12 girls, actually, how many boys do we have? Well, we have our proportions set up. 3 over 4 equals x over 12, and you can do some cross multiplying, dividing, or whatever you want to get x in that situation. So that was something else we worked on earlier. But the big thing now that we want to talk about is what do those proportions look like as equations and as graphs. So here we have an equation, P equals 3 times S. Now this equation actually is the perimeter of a equilateral triangle. That's when all the sides are the same, equilateral triangle, so S, S, S. So the perimeter is going to be S plus S plus S, but if all the sides are the same, taking 3 times S gets you that perimeter faster. So you're just taking, if our side length is 1, 1 plus 1 is 3, or 3 times 1 also gets you to 3. So this is just an example of an equation that is proportional. This one is proportional because we have that common factor or multiple. And they show that by taking P divided by S. So 3 divided by 1, you get 3. 6 divided by 2, you get 3 still. 9 divided by 3, you get 3. Or if you look at it this way, 1 times 3 gets you here, 2 times 3 gets you here, 3 times 3 gets you here. Okay, so this is an example of a proportional equation, and they're always going to be in this type of form, and I'll point that out in a second here. This would be a not proportional. This is y equals x plus 2, just some equation. And if we put 1 in for x, we get 1 plus 2 is 3. If we put 2 in for x, we get 2 plus 2 is 4. 3 plus 2 is 5. That's where we're getting these. And we can see if we do y over x, we get 3. 4 over 2 is 2. 5 over 3 is just 5/3. And that's what a not proportional equation would look like. So usually these ones are a little harder to work with than these ones, because there's not that commonality to it. Check my time there. Okay. And going with that, proportional relationships look like the graph above, this one right here, and I'm going to talk about that in a second. And as equations, they are in this form. Y equals m times x. And m is just some numbers. So for instance, well, and y and x are variables. Like the one we just saw, P equals 3 times s, 3 times the side length. That is in this form, y equals mx, where m is just some number, and then you've got 2 variables on these sides. So this is the format that a proportional line or equation would look like, okay? And then remember that other one that we had was y equals x plus 2. This is not a proportional line or a graph because, or equation, because it is plus 2. If this was gone, then we'd be okay, just with y equals x, because that's technically y equals 1 times x. That would be in that form, but with that plus 2, it's not, okay? So really the only thing, if we're given a bunch of graphs to look at and they say which one's proportional, we're looking for a function that is linear. That means it's straight. So we have to have a straight line, and it has to go through the origin. The origin is that center part, okay? So if we have something like this, that's proportional. This would be proportional as long as it goes through the origin. Wasn't my best drawing. Okay, so as long as it goes through the origin, it's a straight line. Doesn't matter what direction. These would be considered proportional. It doesn't even have to pass through it. It could just start right there. That's proportional. This is proportional still. As long as it's straight and it touches the origin, it will be proportional. So an example of a non-proportional graph could look like this. This is not. Touches the origin, but it's not straight. It's got a bend in it. Not proportional, a straight line like that, but it doesn't go through the origin. or anything that's curved, okay, not proportional, alright? Has to be straight, has to touch the origin. Okay, last thing we need to talk about. Right here. This was one of the test questions on the practice test, and it says which one of these is a proportional relationship. I'm going to rewrite C and D. N equals 4 over P. N over P equals 3. Okay. So really we're looking for the one that's in this form. Y equals m times x, where this is some number. Except for now we're using different variables. So it'll look like n equals m times p. Our two variables are n and p. We need a number right here. None of these look like they are in that form. However, if we manipulate them a little bit, it might. I can tell you right now, this is wrong. Okay? We don't want A. A is not in this format because we need the number to be right here. Okay? This is n times p equals 5. That's not what we're looking for. N equals 2, it only has one variable. If we were to actually graph this line, it would not be proportional. That's gone. You need two variables to have a proportional line. So it has to be C or D. And I'm going to take D. D happens to be the correct answer. I'm going to bring it up here. Okay. Really this says n divided by p equals 3. That's a common factor. No matter what n is, no matter what p is, we get 3. So our common factor is 3 there. So what we have, if we set this up, I'm going to rewrite this. N over p equals 3 over 1. Because 3, I can rewrite as 3 over 1. And remember those, I can make it look like this form right here by doing the cross product. Because the cross products will be equal. So n times 1 is n, because 1 times anything is itself. And p times 3 is 3p, or 3 times p. Okay? That is in this form right here, where m is the number 3, and n and p are our variables. Okay? So D would have been the correct answer there. Alright, so we'll be dealing with this a little bit more tomorrow as well.